Welcome to a lesson with Dr. Powell. Let's talk about how complex numbers and vectors really are kind of the same thing and kind of how they work a little bit. All right. A vector is an arrow with a direction, has a direction and a length. And how do you add two arrows together? It's kind of a simple idea. Basically, what you do is you pick up one of the arrows and you put it at the end of the other one. So it's gonna like you take this one, you pick it up, and you put it at the end of the other one, and then you see what the net arrow is from um, beginning to end, and that's the sum. That's how you add. That's how you add two vectors together. Not too bad. You just go from initial tail to ending tip, and that's the way you add. So you have a vector here and a vector here, and you can add them. In a like manner is subtraction because, well, you have this plus this is that. So guess what? This vector minus this one is this one. So this vector, call this one C, and A and B. And usually we use this notation for vectors. Okay, so if you take C and you subtract A, you end up just getting B. So if you have two vectors, this often happens coming from the same point like this, and you subtract them, like if you take this one minus that one, you end up getting a vector going like this, where the tip actually hits the one that's positive in the subtraction, and the tail is at the point that's negative. So if this is C and A, and this is B, then quite literally, so since if you're doing if you're subtracting A, then that's where the tail is here. And then the tip is right here. But you can also see that as you add. So A plus B will give you C. Okay, so we kind of have this neat description for adding for adding. And this also works if we think of the following. If we put this in a grid in a coordinate system and thought about coordinates here, suppose that so let's look at this. Initially, we had a vector over here. And suppose that this one was something like, and we use this notation for tips, the tip of the arrow. And let's suppose that this beginning is always just 0, okay? So we start at the origin, we go to a tip. And suppose that this tip right here would be something like 1, 2. And suppose that this one is something like 3, 1 or something, then then quite literally what you're doing is like you're taking this picture and lifting it and putting it here. You're shifting this over here. And what do you shift it by? Well, I mean, like you're shifting this picture by this. I mean, like you're raising this point up to there. So you're going up 1 and you're going over 3. So basically to get right here, you're just shifting this by those. So you're just like adding them. You're just adding them together. So you can just add components. This is just quite literally 1 plus 3 is 4. 2 plus 1 is 3. You've just added the components. So that tells us something. If we thought of this as a complex number in the complex plane, okay, this 1, 2. So if we thought of it as like 1 plus 2i and thought of this guy as 3 plus I, then the addition of vectors is nothing more than just adding those two. So 1 plus 3 is 4, and 2 plus 1 is 3. And we got it. All right. So we just adding complex numbers is the same thing as adding vectors. So that's a common thing. And one thing with terminology, notice how when I have vectors, I use little arrow thing like that. That kind of represents a vector. Here with our notation. For a complex number, usually I don't use any arrows like that. Here, I just did this because it was easier to write than that. That's common for shorthand. And yeah, I think we're good here. All right. And thank you for watching.